exponential functions. To do that, we first differentiate. We see that if we integrate the derivative, we get the primitive, which is equal to itself plus c, and write it down. And if I differentiate that using the chain rule, you get 1 over a times a e to the power ax plus b. The a cancels, like that. Therefore, if I integrate this thing, I get the original, which is 1 over a e to the power ax plus b plus c. Yep. Alright, so that demonstrates where this rule come from. These are on your formula sheet. That one is on the on formula sheet. Okay, and you can find it on the formula sheet somewhere. Open formula sheet. Okay, so write it down. So let me find the formula sheet, reference sheet. Reference sheet. Reference. That's reference sheet. Okay. Alright, let's do a few questions. So we use the formula sheet. So this one here, you get 5 e to the power x over 3. And then using this rule, you divide 1 over a. So on the formula sheet, you'll find it over here. Yeah, the second one. Okay, so the second one here, that's the formula sheet. So that's what you're given. And then we'll go back. So using this rule, you have to ignore the 5 and then times by 1 over 1/3 plus c, like that. And when you do 1 over 1/3, you get 3 e to the power x over 3 plus c. And then you get 5 times 3 is 15. Right, we get that. And do the same thing for the next one. Next one's the same again. Take the a, so your a is -2, so you get 1 over -2 e to the power 7 minus 2x plus c. And just by -half. Alright, done. Any question? Alright, pretty basic. So you will only be expected to integrate things with this. This is a very simple one with a linear ax plus b, only in this form. Right, and then we'll do a definite integral. Right, let's try a definite integral. Integral will be -half e to the power 5 minus 2x. Put in the numbers, 3, 2. Okay, leave your answer in terms of e, exact form. Okay, have a try. Alright, -half e to the power of -1 minus -half e to the power of 1. Double minus, and then you get -1 over 2e. Double minus is plus e over 2. Alright, like that. Any question? Okay, so let's just show you the topic again. Right, after this, go to the next page, we'll do some graphs. I'll finish. Okay, let's go through some graphs. So we'll do the first one, e to the power x. So we'll do a table of values. The e to the power 0 is 1. E to the power 1 is e, which is 2.7. And then use your calculator for e to the power of -1. E to the power -1. You get 0.36 to 0.4. Okay, so now we just plot the points to draw the graph. Let's make this one. Yeah, make this one -1. So 2 is about here. Something like this to 0.4. So like this. Okay. Alright, for this graph, and this graph have an asymptote at y equal to 0. Asymptote. With the equation y equals to 0. Okay, so write down y equal to 0. Features, yep, okay, like that. And then draw the other few. See the transformation with the negative x. I'll do the table value for the next one. So the next one, if you have negative x, when you substitute -1, you get 2.7. You get 1 and then 0.4. So you'll see that the graph's being reversed. One with the same asymptote. Okay. Right. For the next few, see what you observe. Alright, let's finish the rest. And what do you fill out? What do you observe? If I say reflect about x-axis, about y-axis, reflect about y-axis, I'll reflect y equal to e to the power x about y-axis. Okay. Okay, good. And the rest, this will be -0.4, -1, -2.7. Right, like this. And then you do this. Okay. And then you do the next one. You get -2.7, -1, and -0.4. Get this. Alright, okay. So these are all the graphs. And then make sure you write down the transformation. So you have a negative in front. That tells you it's going to be reflected about x-axis. Reflect y equal to e to the power x about x-axis. And the last one you say reflect this one, e to the power -x. E to the power of -x about x-axis. Alright, okay, so remember all the transformations. That will help you to draw graphs. Okay. Alright, after we do this, we need to do this for integration because we need to know how to draw the graph. For integration, when we find the area under the graphs. So go to the next page. Alright, we'll do area and volume, then that's finished. Alright, let's do the first question. Find the area bounded by the curve, lines, x-axis. So you draw the graph. So we know it looks like this. Has an x-intercept of 1. Goes up like this. And the area bounded by the graph is between x equal to 1 and x equal to 3. And then if you shade below, it looks like that. Alright, it's all positive, so no problem. So we say area is, write down the general formula, y dx from a to b, and then substitute. Okay? So a to b will be 1 to 3, y is e to the power 2x dx. Once you write down the integral, the rest are quite easy. Okay, have a try. Alright, so we get e to the power 2x is e to the power of 2x half. Alright, and then you get 3 and 1, and then substitute 3, you get e to the power 6 minus e to the power 1, e to the power 2 half. I think you just leave it like that. Leaving in exact form. Square units. Yep. Done. And the next bit is, how do I calculate volume? Well, volume, you just write this another formula for volume, the generic formula, V equal to pi y squared dx from A to B, and follow through. Okay, have a try. Okay, alright, y squared, so you go e to the power 2x square dx from 1 to 3 pi, and you have to square it before you integrate, so you get e to the power 4x dx, and then you get pi over 4 e to the power 4x 3 and 1, okay, and then you get pi over 4 e to the power 12 minus e to the power 4. I think that's it. You don't need to factorize. Alright. Okay, that's it. Goodness. Shoot. Alright, volume's done. Okay, any question? All done? Right, next we do primitive. So given y dash is this, y dash is that, you have to find the primitive. So you do y is that, and then find out what c is. Okay. So you integrate, so you get y equal to e to the power x minus 1 plus c. Find c where x is 1, y equal to 1. And then you get 1 equal to e to the power 1 minus 1 plus c. 1 equal to e to the power 0. E to the power 0 is 1. So you get 1 equal to 1 equal to c plus c. So therefore c is 0. And then you make sure you update the formula. Therefore y equal to e to the power x minus 1. Right, that's the final answer. Right, all done. Good. And then followed by 3 indefinite integrals. They are a little bit harder. You do have to use index law before you use the formula. So how do we do this? Make sure you always try to write it in this form. So write it in this form here. Okay, so make sure. So these one are not in this form, so you have to use algebra to write it in this form. So let's do this. So the first one, use the index law. Write 1 over e to the power of 2x dx. That's your first step. And then you write it in negative index, e to the power negative 2x. Then you use the formula. Okay. And then you get e to the power of negative 1 negative half, e to the power negative 2x plus c. Okay. Alright, try the next two, see if you can write it in the form of, in the index form. Okay, write all of this in index form before you find the primitive. Okay, so to the next one, e to the power of x. Now, square root means half dx. Half is e to the power half x plus, and then dx, like that. And then use the formula 1 over half e to the power half x plus c, which is 2 e to the power half x plus c. Okay, done. Alright, try the last one, see what to do when there's a fraction. Have to remember what to do. Alright, last one, so we do, So you have to split the fraction into two if it's one term in the denominator, like that. And then you get 1 minus, and then use index law, negative x minus x dx. And then you do e to the power negative 2x. Then you find the primitive. Okay? Alright, so find the primitive of 1 is x minus 1 over negative 2 e to the power negative 2x plus c. And then you simplify, double minus is plus, so you get plus half e to the power negative 2x. Alright, we'll finish all the topics before your exam so you can start doing revision. Okay, so you can start the work today, exercise 4.3.